Rosalind Franklin was born in London in 1920. She showed a keen interest in science from a young age. She excelled in her studies, particularly in physics and chemistry. Franklin attended one of the few girls' schools in London that taught physics and chemistry. She later earned a doctorate in physical chemistry from Cambridge University. During World War II, Franklin made significant contributions to the war effort. She conducted research on the porosity of coal. This research helped to improve the efficiency of gas masks. After the war, Franklin turned her attention to the study of X-ray diffraction. This technique allowed scientists to study the structure of molecules in great detail. Franklin quickly became a leading expert in this field. Her expertise would prove crucial in her later work on DNA. In 1951, Rosalind Franklin joined King's College London as a research associate. Her task was to investigate the structure of DNA. Using her expertise in X-ray crystallography, she captured high-resolution images of DNA fibers. Her most famous image, known as Photograph 51, was instrumental in the discovery of DNA's double helix structure. This photograph, taken in 1952, clearly showed the X-shaped pattern characteristic of a helix. It provided crucial information about the dimensions and angles of the DNA molecule. Franklin's meticulous approach to data collection and analysis was critical to her success. She carefully controlled the humidity levels of her DNA samples. This allowed her to distinguish between two forms of DNA, the A form and the B form. While Franklin was meticulously collecting data, James Watson and Francis Crick at Cambridge University were working on their own model of DNA. Unbeknownst to Franklin, Maurice Wilkins, a colleague at King's College, showed Watson and Crick photograph 51 without her permission. This unauthorized viewing of her data proved to be a turning point in the race to solve the structure of DNA. Watson and Crick were able to use the information from Franklin's photograph to build their now famous double helix model. They published their findings in the journal Nature in April 1953. Franklin's contribution to the discovery of the double helix was not fully acknowledged during her lifetime. The 1962 Nobel Prize in Physiology or Medicine was awarded to Watson, Crick and Wilkins for their work on DNA. Sadly, Franklin had passed away 4 years earlier from ovarian cancer at the age of 37. The Nobel Prize cannot be awarded posthumously. However, many believe that Franklin's contribution to the understanding of DNA was equal to that of her male counterparts. Her story highlights the challenges faced by women in science during that era. Despite not receiving the recognition she deserved during her lifetime, Rosalind Franklin's legacy lives on. Her meticulous research and groundbreaking discoveries paved the way for a new era in molecular biology. Today, numerous awards, scholarships, and research institutes bear her name. Her story serves as an inspiration to aspiring scientists, especially women around the world. Rosalind Franklin's contributions to science, though initially overlooked, have left an indelible mark on our understanding of life itself.